Hey you guys, this is Mr. Millings and welcome to part 4 of challenging mole conversion problems involving density and shapes. And in this video, we are going to be working with some more cubes. So let's take a look at an example. In this example, it says a scandium cube is made up of 7.96 times 10 to the 29th atoms. We need to determine the side length of the cube in centimeters. And also, we need to round our answers to 3 significant figures. So in this problem here, we have a cube, and what I like to do in these types of problems is draw myself a little picture and label what's going on. That way I can visualize everything. So we have a scandium cube, and Sc is the chemical symbol for scandium. And what do we know about this scandium cube? Well, we know that this scandium cube here is made up of 7.96 times 10 to the 29th atoms of scandium. And so what we're asked to figure out is, if we know this is scandium and we know it's made up of 7.96 times 10 to the 29th atoms, then what will one of these side lengths be? What is the side length of this cube going to be if all we know about this cube is that it's made of scandium and the number of atoms that it's made up of? How can we figure that out? Well, let's think about this. If we know the material and we know the number of atoms that it's made up of, then what we can do first is we can first use the mole conversion diagram that we see right here to figure out the number of grams that this scandium cube weighs, or what the mass of this scandium cube is going to be. So in our very first step, what we're going to do here is we're going to do some mole conversion to determine the mass of this cube. Once we figure out the mass of the cube, what can we do next? Well, let's think about this. If we know the mass of the cube, can't we figure out the volume of the cube by using the density formula? That's exactly what we're going to do. So once we figure out the mass in grams, in step 2, what we're going to end up doing is we are going to use the density formula. Density equals mass divided by volume, and we learned this in an earlier video. And what we're going to solve for is volume, right? Once we figure out the mass in step 1, we can plug it into here. We can then look on a table, or we can Google what the density of scandium is. And then we can solve for the mass. We can solve for the volume. We can solve for the volume. Once we're done figuring out the volume, what we can do in our very final step is, in step 3, we know that volume of a cube is going to equal one of the sides cubed. So if we know the volume, we can plug it into here and solve for S. If we figure out the volume in step 2, we can plug it into here, into this formula right here, and solve for S. So let's go ahead and start with our very first step. In step 1, what we're going to do is we are going to determine the mass of this cube. So we can figure out the mass of this cube by taking the amount of atoms that we're starting with. So we're starting with 7.96 times 10 to the 29th atoms of scandium. And what we want to do with this is we want to figure out the number of grams, or the mass, of this cube of scandium. So we need to cancel out atoms of scandium, and we need to convert to moles of scandium first. So if we want to cancel out atoms of scandium, where do you think we're going to put that in this fraction or equivalent statement? You guessed it. Units can cancel out just like numbers do. So if we put atoms of scandium on the bottom here and moles of scandium on the top, then these two units will cancel out. Once we're done with this little step, we're going to want to cancel out moles of scandium. So we're going to put that at the bottom of our little equivalent statement here, and then we're going to convert to grams of scandium. So, what's the relationship that exists between moles and atoms? Well, 1 mole, if you remember, is 6.02 times 10 to the 23rd of whatever it is you're talking about. In this case, we're talking about atoms of scandium. And now, what is the relationship between grams and moles? Well, if you take a look at the periodic table that just popped up, you will see that the molar mass of scandium is 44.96. So what does that mean? That means for every 1 mole of scandium, it's going to have a mass of 44.96 grams. So now we take our calculator and we start with the given quantity. We work our way from left to right. If we come across a number other than 1 in the denominator, we are going to divide. If we come across a number other than 1 in the numerator, we're going to multiply. So when we take 7.96 times 10 to the 29th divided by 6.02 times 10 to the 23rd times 44.96, we're going to end up with 5 and we'll put the answer down here where there's room. We're going to end up with 5.94 times 10 to the 7th. What unit is left over? Well, if we take a close look here, let's see what ends up canceling out. We have atoms of scandium on top and bottom. They will cancel. We have moles of scandium on top and bottom. They will cancel. And so the unit left over here is going to be grams of scandium. But this is not our final answer. This is just the mass of this cube. What we now need to do is we now need to use the density formula and figure out the volume of this cube. So let's do that. If we know that density equals mass divided by volume, and we're going to try to figure out what the volume is, then we need to isolate V all by itself on one side of that equal sign. So we'll first multiply by V to get rid of the fraction here. We'll multiply V on both sides. And so now if we take a look, we have mass equaling volume times density, but we want to figure out V. We want to get V all by itself on one side of that equal sign, so we're going to divide by density on both sides. Density cancels, and so to get the volume here, we simply take the mass and we divide it by the density. So what is our mass? Well, we just figured that out right here. Our mass of this cube is 5.94 times 10 to the 7th grams. And if we take a look at the table that just popped up, you can see that the density of scandium is going to be 2.985 grams per cubic centimeter. So what ends up happening is grams in the numerator here and in the denominator here cancel out. And when we take 5.94 times 10 to the 7th and divide this by 2.985, we end up with 1.99 times 10 to the 7th. So our volume is going to equal 1.99 times 10 to the 7th centimeters cubed. So now this is our volume, but we're asked to figure out what the length of one of the sides is. So what we now have to do is we have to plug that into this formula right here. We know that the volume of a cube is equal to the side cubed. So how do we figure out what one of the side lengths is? Well, we have to get S all by itself on one side of this equal sign. So the way that we get rid of this cubed root here, the cube right here, is to take the cubed root of this entire thing. And if we take the cubed root of this side, then we have to take the cubed root of the left-hand side too. And so, to get the side length here, we are simply going to take the cubed root of our volume. So, let's go ahead and do that. We're going to end up taking the cubed root of 1.99 times 10 to the 7th centimeters cubed. And so when we put this in our calculator, we can put this in our calculator a couple of different ways, but this right here, this expression right here, is essentially the same thing as 1.99 times 10 to the 7th centimeters cubed, all to the 1/3 power. And so, depending on what type of calculator you have, you can enter this expression in like this, or you can enter it in like this. And either way, you're going to end up with a side length of 2.71 times 10 to the 2 centimeters. And so, to recap, if we have a scandium cube that is made up of this many atoms, what will one of these little side lengths be right here? We just figured it out. 2.71 times 10 to the 2nd centimeters. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner. That's going to subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.